Hello everyone. Today we are going to discuss about the some basic introduction about the automotive sensors. So basically, sensors plays a wide role in almost in all the segments, maybe manufacturing, robotics, in all the aspects. But in similarly in the automotive side also the sensors plays a wide and major aspective role in its basic function and related aspects. So, what is the specific requirement of this sensor with pertain to automotive? So, what are the different types of sensors, or what are the characteristics features of the sensors which needs to be considered for the selection for any sensing technique? So, these are all we are going to see in this section. So basically, if you will see the sensors which is used for automotive applications can be classified into very wide varieties. For example, the sensors which can be applicable towards the drivetrain related aspects, comfort and convenience related aspects, like similarly the safety related aspects more importantly. For example, anti-lock braking system related sensors, or the cruise control related sensors, or the autonomous part related sensors. So, and of course, drivetrain related sensors also there. So basically, wherever we are using the ECU, okay, so wherever we are using the electronic control unit, so there definitely there is a presence of some sensors are there. So the number of sensors may be varied from vehicle to vehicle or system to system. Typically, if you will say a higher class vehicles may have up to 300, 400 sensors also. Maybe the middle level segment car might be having less number of sensors. So depending upon the cost and the requirement and complexity, the number of sensors used will be varied. So why? What factor which makes the more number of sensors to be used in the vehicle means ultimately the better comfort, convenience, all those things aspect. If you want to, for example, in some vehicles there is a seat adjustment system also there. So, but most of the Indian vehicles are the cost of the vehicle which is less than 10 lakhs at all. There is a seat adjustment is there, but it is done by manually. So if you want to make it in an autonomous way or automatic way, so in that case there is a need of a sensor. So depending upon the requirement and the technology advancement, the number of sensors can be varied. So it will be varied from tailpipe to the bumper in any case. For example, if you see in the right corner, AdBlue related sensor. AdBlue is nothing but a SCR system from the BS6 or the Euro 6 onward. This AdBlue technology has been used in the what you call diesel engines especially. So there is a presence of sensor. Similarly, if it is a hybrid vehicle also or electric vehicle also, depending upon the requirement, the motor temperature sensor, like battery related sensors, so all those things. So the number of sensors we can't able to restrict. Only this many number of sensors has to be used, or this many sensors are not there like that. So depending upon the requirement of the vehicle and the functions, and of course the what you call the customer demand, the number of sensors in the vehicle can be varied. So ultimately, what factors which will decide the selection of the sensor? So on what basis we have to select a sensor? So there are a lot of factors which needs to be considered. For example, what has to be measured, whether there are many signals are there. It varied from mechanical signal to the thermal signal, chemical, what are different physical signals are there. So what signals needs to be measured? So what is the range, magnitude? So what is the range? For example, a temperature measurement is itself range can be varied. For example, if you want to measure a room temperature, means there is a range will be different. If you want to measure a combustion chamber temperature, or if you want to measure exhaust gas temperature, so depending upon the requirement, the range and the dynamics of the measured quantity, all those things has to be considered. And what is the accuracy, all those things. And similarly, whether it is active type or a passive type, and analog output is in the form of analog way or a digital way. So all these factors needs to be considered. So that's what we will call as a sensor operational factors. It will vary from cost, weight, size, accuracy, repeatability. So these are the different factors which needs to be considered before selecting any sensor. Not only for automotive application, but for any application, if you want to select a sensor, number of factors. So basically, we will call it as a static and dynamic characteristics of the sensor. So that factors needs to be considered well effectively before the selection of the sensor. So that's what we'll call as a sensor characteristic. So it will be depending upon the sensitivity. That is nothing but for a sensitivity is how much stimulus the range or with respect to the input to the output, how it will be affecting. Similarly, accuracy, what is the speed of response, at what speed the signal will be responded. Overload characteristics, operating band, environmental condition. Because especially if you take in case of automotive segments, the sensor needs to be operated in a very wide, rugged operating condition. It has to operate in too much vibration. That even especially the engine related sensors, it has to operate in too much vibration, temperature, and noisy, and as well as the oily surface, all those things. So the requirement of automotive sensor, and if you will compare with the requirement of the robotics related sensors, it will be totally different. So of course, robotics also used in case of heavy manufacturing places also. But I am saying in a light temperature application, or a generalized applications in the whatever air conditioning room or like that. So accordingly, the requirement will be varied. And another important thing is that the sensor materials. So it may use a conductor material, semiconductors, and as well as some kind of biological substances also. For example, if you want to measure any kind of biological related aspects of the functions, so there, for example, any chemical related thing, so there it may use as a particular biological related substance, and specifically made materials, a liquid, some kind of gases or plasma technologies also used. And by means of using a sensor, you can able to detect varieties of signals. It may be a biological signal, it may be a chemical signal, electric signal, or a temperature, mechanical displacement, radioactive signal. So all these different varieties of signals can be measured with the help of sensors. So what are the typical characteristics of a sensor? So basically, selecting a sensor before for any application, these two important main characteristics needs to be considered well affected. One is the static characteristics and another one is the dynamic characteristics. So in the static characteristics itself, there are different parameters are there needs to be considered. So it is nothing but a set of performance criteria of a particular sensor that will give the quality of measurement without becoming concerned with the dynamic description. So without in a static way, in the static conditions, it will give the quality of a particular sensor, whether the output of the sensor can be in a quality way or not. It will able to judge if the static characteristics of a particular sensor is this much range. In the static characteristics, there are a lot of types are there: the accuracy, precision, range, sensitivity. So all these functions are the factors needs to be considered. So by considering all these functions, you can say the static characteristics of a sensor is this much thing. So accordingly, the quality of the sensing out will be this value, like that we can able to judge. So if you come to the dynamic characteristics, it will give the quality of the measurement when the measurement quality is varied with the time. So it is during the dynamic applications. So according to the time, how the sensing information or the sensor output can be varied. So here the dynamic relationship between the instrument input and output must be examined generally using a set of differential equations. So according to the differential equation representations, so how the quality of the sensor output, how the quality of the measured value can be varied with respect to the time. So that will describes the dynamic characteristics of a sensor. So if you will come to the static characteristics, there are more number of parameters are there, like static sensitivity, linearity, precision, accuracy, resolution, hysteresis, range and span. Similarly, other more parameters are there. One by one we will see. So while selecting sensor, we must need to consider all these factors. We must need to consider all these factors in a very serious way. And according to the application, the characteristics of the sensor will be varied. For example, if you take the same pressure temperature sensor, the temperature sensor used in the engine application, the static characteristics will be differed. If the similar type of temperature measurement used in cabin measurement inside the vehicle and the car, so in that case, the static characteristics will be different. So depending upon the place where the sensor will be used or applied, so there the static characteristics and of those sensors will be varied. So coming to the dynamic characteristics of the transducer refers to the performance of the transducer when it is subject to the time varying input. So the number of parameters required to define the dynamic behavior of the transducer or the sensor is decided by the group of transducers. Like we will say that it will be classified into zero order, first order, higher order transducer. So according to the time domain or time value, this output of these transistors or even transducers will be varied. So the very first one is the accuracy and precision in terms of what you call static characteristics. Sorry. So if you will take in case of accuracy, that is it will determine the quality of parameters, how precise and accurate the sensor value. For example, if you see in the figure, so the sensing information is not in a concise towards a particular confined to the particular place or the particular range. We will say that the accuracy and precision is not good. So the if the accuracy and precision of the particular sensing material or the sensor is good, then only we can able to get a better output results. So the accuracy is the ability to give the results which is close to true value. Exactly in a 100% of true value, definitely we will not get in a most of the sensors, but it is very rare and tough to get a what you called it to get a 100% accurate value, but close to the true value we will get. That determines the accuracy. So next one is the absolute error, that is the obtained value, the difference between the true value and the obtained value. So accordingly we may able to get a relative error. So this error should not be very much high. So if this error again is too much high, then what it indicates that the sensor sensing characteristics or the sensor output characteristics is not that much reliable. So if you are going to use a sensor for any application, so its accuracy should be in a very much appropriate way. Then only the output error will be comparatively lesser. So the next one is the sensitivity. The sensitivity is defined as the ratio, what are the between the output signal of a particular sensor and a measured property. So the sensor can be used to measure a temperature, pressure, or what you call the position, displacement, angle, or anything. So, but the output of the sensor will be in the form of voltage most of the time. So, in that case, it determines the ratio of the output voltage, output signal, and as well as the measured property. For example, if a sensor measures a temperature and has a voltage output, the sensitivity is constant with units. That is the voltage with respect to the Kelvin. So that's what we will call as the sensitivity. So if you see the ideal sensitivity represented as the straight line, but whereas true sensitivity is represented as a what I call deviation between the ideal conditions. So that is the slope which is we are getting. So that's what we will call as the sensitivity, which is nothing but the relation between the output the signal of a sensor to the input sensing value. So next one is the range and the span. So it is nothing but a range. It is the minimum and maximum value of a physical variable which that sensor can able to measure. For example, if you take in case of temperature sensor, that is RTD, some type of a temperature sensor. So if it has a range of -200 to 800 degrees Celsius. So this type of sensor can be used in the measurement of higher temperature application. For example, if you see the exhaust gas temperature measurement, this particular range is feasible, but no need to go for a -200 degrees Celsius in this case, in the particular example I am saying, because the exhaust gas temperature of a typical IC engine will be varied from to 150, or you can say it will vary from 100 to 400 or range. So in this case, this range will be not suitable, or it is very much too wide. So in that case, the accuracy will be affected. So that's why while selecting a particular sensor, the range has to be in appropriate value to get a final output accuracy in a very appropriate way. So next one is the span. Span is nothing but the algebraic difference between the upper and lower range values expressed in the same unit range. For example, in this case, the span of a particular span value of this particular RTD is in the range of 1000 degree Celsius. So this particular value has to be selected in an appropriate manner to give the sensor output in a quality way. So the next one is the linearity. So the linearity of a particular sensor is nothing but it is a deviation between the measured value of a sensor from the ideal curve. So for a particular sensor, there is a what you call ideal characteristics curve will be there. So the ideal characteristics curve is nothing but the variation between the input towards the output. So for example, input here is the sensing value, or you can say the sensing signal, and output is the corresponding voltage. So the deviation between the ideal curve to the measured value, you will call it as the linearity. And other important static characteristics which needs to be considered while selecting a sensor are resolution, which is nothing but it is a minimum change in the input that can be sensed by the sensor. For example, if you are going to use a particular sensor, say a temperature sensor, there the what you call temperature measurement will be in the range of up to minus 52 plus 50 degrees Celsius. In that case, you should not use the range of 800 degrees Celsius measurement sensor. So there the what you call finite range has to be used. Then only the resolution of the sensor will be very much fine. So at what instant or what value the out or for what value the sensor can able to give the output, that's will call as the what you call for small change how much value it will give, that will call it as a what you called resolution. Then next one is the reproducibility. Reproducibility is defined as the ability of the sensor which produces the same output when same input is applied. See, for today the sensor will give for the same input condition, it will give some input value, output value, and tomorrow for the same input value the sensor should not give the different output value. So the repeatability has to be in a such a way that it has to what you call it sorry, it has to be in a very much finer manner. Reproducibility has to be in a very much finer. So in other case, the repeatability is the same ability of sensor to produce the same output every time when the same input is applied, and all the physical and measurement conditions kept, including the operator, instrument, and ambient conditions. See, for example, yesterday you have measured at one temperature and the noise under one environmental condition. Today, again, if you are keeping it the same condition, same environmental condition, that is the external disturbance, it has to give the similar value. Then only the what you call the output characteristics can be a reliable one. Otherwise, the output characteristics of the sensor will not be a reliable one. See, for because if you take the exhaust gas oxygen sensor, see for today it is giving one input and tomorrow it is giving in another input. Then what will happen? Ultimately, it will affect the air fuel ratio of the particular vehicle, and it will give the negative impact on the fuel economy. So the main important aspect is the reproducibility and repeatability of the sensor has to be very much appropriate in the entire operating span. So with either with presence of disturbance and without the disturbance also. And next the important parameter is the response time. Response time is generally expressed as the time at which the output reaches a certain percentage of its final value in response to a step change in input. For example, if you are giving a step signal as input, so how much instantly it is responding to reach a 95% of its whole thing. So that's we will call it as a response time. So for example, if you are if the again say the exhaust gas oxygen sensor you are using, so immediately after the end of the exhaust stroke, the sensor has ability to respond immediately. So it should not take certain duration of time. But say example, same EGO sensor, it can able to operate more than 230 or 250 degrees Celsius. So till that it response of those sensor is very low or it is not usable. So in that case, the response time of a sensor also has to be considered effectively before selecting for the any applications. And coming to the dynamic characteristics, it again as I discussed, according to the what you call time variation, the sensor output characteristics has to be tested, or it has to be, or it will be varied. So for example, it may be for a capacitance type, or it may be any type of other type of sensor. So if you, in this case, varieties of inputs with respect to the time are applied. For example, either impulse input, step input, or a sinusoidal, or a what another type of inputs, it will be given to the sensor, and accordingly according to the time how the sensor output will be varied. So that also has to be considered. Sorry. So to sum up, the automotive sensor has a different requirements as compared to the other type of sensors which is used in the general applications. If you take in case of automotive sensors, it should be have the high reliability, because depending upon the high reliability only it can able to operate at a what you call a rugged environment and all those things. And of course the manufacturing cost has to be lower, then only it can able to go for a efficient mass production. Cost of the sensor also should not be very much higher. Severe operating conditions, then only it can able to the packaging or the operating conditions has to be in a well effective manner, because not like a normal regular sensor. For example, in a mobile phone itself we are using the more number of sensors. So it is the case like that in the mobile phone, it is not able to operate in a very rugged environment at all. But whereas in case of automotive sensor, it is supposed to operate in severe operating conditions. And of course the size of the sensor has to be very much small, then only miniaturization technique like MEMS based sensor, all these things will be used for measurement. And similarly it should provide the higher accuracy, then only the what you call the output of the sensor can be will effectively used for controlling any particular parameter in the ECU. So these are all the different requirement of a automotive sensor. So ultimately where we are using this sensor. So generally we are using this sensor in case of a control system for controlling some parameters, or generally this sensor will be used to measure some kind of physical change. So by means of getting the sensor value, what we are supposed to do. So for example, we are altering the plant output. So generally in case of open loop system, the input you are giving to the plant and output it will produce. So we are not worried about what is happening in the output. So there the sense there is a no role of a sensor over there. But whereas if you will comes to the closed loop system, so where the feedback will be provided with the help of the sensor. So in that case the sensor act as a, it will compare the actual value to the reference signal, and according to the deviation which is whatever happened between the reference signal and the actual value, it will controls the plant output. So for this purpose only the sensor will be used. So what type of signals can be measured by means of using the sensor, like mechanical signal, thermal, magnetic signal, electrical signal, like electric in the sense, for example, how much voltage, how much current is going in a particular circuit in case of battery, like that. And similarly chemical related aspects and radiation related signals. So all these signals can be measured with the help of a sensor. So now comes to the definition of a sensor. So what is a sensor? So till now we have discussed about what are the characteristic features of the sensor, what needs to be considered, what are the important points before selection of a sensor and all those things. Then first of all, what is a sensor? So a sensor is a device that receives and responds to a signal or a stimulus or any kind of physical change. So the sensor converts any type of energy into electrical energy. So it is a type of a transducer also. So transducer is nothing but converting one form of energy into another form. But sensor again, it will measures any kind of physical signal and it will convert into another form. For example, temperature is a physical change. The converting the temperature signal into the electrical signal. So it is the it has integrated of a transducer as well. So it is a transducer used to detect the parameter in one form and report it in the another form of energy. Example, a pressure sensor detects the pressure, that is a mechanical form of energy, and converts into the electrical signal, either for a display or for a control system purpose. So a sensor is a device that receives the stimulus, that is a measurement value, and response within the electrical signal. So before a sensor can sense giving the electrical signal, it has to convert into a one form of energy to the another form. And another important thing is that there may be one or two transducers also may be inbuilt in a sensor. For example, for a single stimulus, say the chemical sensor produces the electrical signal in response to chemical reagent. The sensor may have two parts. That is, the first one converts the energy of chemical reaction into heat, and another part is that heat into the electrical signal. So in this case, this particular sensor might have the what we call true transducers. So typically a sensor might converting the one form of signal to another form and another form to another form. So that's what we'll call as a transducer 1 and a transducer 2. So this will put together inside a single sensor. So generally there are two types of sensors based on what you call the direct sensor and known as a complex. That is nothing but a converts measured value into electrical signal or modifies an electrical signal for a physical effect. Complex sensor needs one or more transducers of energy before direct sensor can be employed. So this is the what you call, depending upon the number of transducers or the transaction principles which is followed, we can able to classify it as a direct sensor and another one is a complex sensor. And another important aspect is that the sensor has to provide the output signal with respect to the change in any kind of temperature, pressure, on any external disturbance. So it has to withstand any kind of noises, or and the output, it has to provide the output in an effective manner. So either depending upon the what you call electrical non-electrical quantity, it has to provide the electrical quantity with respect to the disturbance in the system. So this disturbance may be the temperature, pressure, noise, or any vibration, all those things. So as we had discussed, transducer is a device that converts one form of energy into the another form, whereas sensor is a device that will detects or measures a signal or any physical stimulus. And another thing is the actuator. The actuator is nothing but a output of the electronic control unit, or the what you call converting the electrical signal into a mechanical output. So these sensors consist of the maybe the it is the input model which has the either types like resistive type, reactance type, self-generating, smart sensors, all those things. And what are the other components of the sensor? Sometimes it includes signal conditioners, signal conversions, and of course it can be fed into the data acquisition system also. So why signal conditioners is also part of a sensor means, so adapts the signals to the standard form required by the what you call ECU. So sometimes the signal may be more noisy and weak, so measured by the sensor. So that has to be converted to the ECU adaptable signal. So the electrical sensor output are any of the following. It may be a current or voltage or a frequency or a resistance type or inductance type or any value. So generally we can classify the type of the sensor into four ways. So earlier we had discussed about the types based on the transducer integration thing. But this is general classification based on the power source, based on the assignment and application, and another is based on the output curves produced, type of curves produced, and type of the output signals we can classify. So the based on the power source, one is the active sensor and another one is the passive sensor. So here if you will see the in case of active sensor, it might need a external power source. So without the external power source, the sensor won't operate. So we need to provide the external power source like a thermistor. So power source can increase the danger of the explosion in the exposed areas also. So in that case, the power source has to be limited. So here it consists of more number of wires, because compared to passive sensor, if you take in case of passive sensor, there is a no need of a what you call external power source. For example, thermocouple or a thermometer. See, in case of thermometer, according to the temperature, the mercury level is increasing. So there we are not providing any kind of external power source. But whereas in case of the active sensor, we need to provide the power source. So that is the for providing the external power source, we need to provide what you call spent one more wire in case of active sensor. But whereas in case of passive sensor, we need a less number of wires. So that's what the active sensor it consumes the energy and produces the energy, also capable of power gain. Whereas in case of the passive sensor, it consumes the energy but not produce the energy capable of power gain. So it consists of three pins. That is the input to the sensor, ground, and the output value. And whereas in case of a passive sensor, it has a two pins only. One is the output and one is the ground. There is no need of a power consumption thing. And of course, according to the assignment and application, it may be used for the open loop and closed loop system also, for safety and safeguarding, onboard vehicles, engine type, or different according to the assignment and applications. We can classify like temperature sensor used in engine, pressure sensor used in engine, like that. And coming to the classification based on output characteristics, simply a linear signal or a non-linear signal, frequency type also it can able to produce, and of course it can able to produce in the form of what you call PWM as well. The output will be in the form of PWM also. And of course some of the sensors will be bus compatible. It is nothing but it can able to communicate between one sensor to what you called another sensor in the form of not a normal wire through the either CAN bus sort of thing. And according to the output signal, we can able to classify into a analog outputs sensor and another was a digital output sensor. So it can able to provide a direct digital output also. So how means, for example, you can able to see based on this degree of integration. Like a conventional sensor only it has a sensing element, whereas it will the signal conditioning A to D converter everything present inside the ECU or the controller. But whereas unconventional sensor somewhat slightly advanced, the signal conditioning will be present inside the sensing chip itself. The same element it is, or the same component itself consists of a signal amplification system. In another case, A to D conversion. So directly it can able to give the digital signal. So this is what again in the previous slide we had discussed about this digital signal. So this sensor can the signal amplification. This sensor can able to give only the analog value, but this sensor can able to give the digital value. And another advancement is that along with the microcontroller. So this type of sensor can able to have the bus compatible. So here itself, because why? What is the need of microcontroller over here means, so here itself the sensor will measure the value and immediately the sensor information will be processed, and the processed information can be directly given to the ECU. So it will avoid any kind of signal loss, and it can able to give the better quality of the signal also. This either type of sensor can be used in the automotive application. So it is not necessary to use always the last type of sensor. Any type of sensor can be used according to the cost and the requirement. And of course, some of the leading manufacturers which will manufacture the automobile related sensors are Bosch, Continental, Delphi. So according to the requirement and according to the operating conditions and according to the cost, the type and cost of the sensor will be varied. Thank you.